Was a little out of focus there, folks. Hello, how's everybody doing? I hope you're doing fine. Today I'm going to be continuing with geometry, but before I do, I want to cover a little topic that came up during the week related to extinction of man. I was dealing with that subject before, and I want to make sure that some of these loose ends are tied, that we cover them. People understand what the answers to those are. It has to do with the issue of war, and that's been lately on a lot of people's minds. So they brought the issue of war and how that relates to extinction. I mean, if we have world war, 90 to 99% of the people get wiped out. Some people survive. Let's assume that, right? Well, there are several things. Do they engage in trade and save themselves? First of all, do they survive because everybody thinks he's going to survive, not the other guy? I'm always going to survive, not you, okay? And then the other question is whether we're going to reproduce. The population crashed, and now we just start all over again, Adam and Eve. And, people are not aware that trade has not always saved us. And here's a little listing of some of the Russian famines they had throughout their history. These are the documented ones. From 1127 to 1303, at least 11 famine years were recorded for different reasons. Like I show there at the bottom, could be drought, mismanagement, politics. Sometimes it was deliberate to get rid of some people that you didn't want. Another great famine of 1315 to 17, 2 million people, a third of the population allegedly died. 1891 92, 500,000 people. Famous one that is thrown against the communist Stalin, 5 million allegedly died in the 1920 to 1922 years. Trade has not always stepped in to save the day. And the other thing is, these people had money on their hand. I mean, they weren't rich, but they had money. And so what? I mean, they had money but no food. And so, money does not equate to food. Imagine if there is a world war, right? And a lot of the transportation or the routes or whatever are going to be disrupted, okay? So it doesn't mean that you might even have access, you might have $1 million in your house for all I know. It doesn't mean you have access to food. So this notion that people say that, I'll just trade and I'll trade my car for a banana, may not happen. You may not have a banana to trade with someone for. Anyways, I like Dylan's words, Bob Dylan, for those of you who heard of him. And he kind of synthesizes what I'm saying here. He says in his song, Talking World War III Blues, he says, hey, I've been having that same old dreams. I dreamt that the only person left after the war was me. Everybody thinks he's going to survive, right? I didn't see you around in his dreams, right? Everybody's having them dreams. Everybody sees himself walking around with nobody else. Yeah, and he also answers the other question that I just raised about Adam and Eve in the same song. And he says, I spied a girl, and before she could leave, I said, let's go and play Adam and Eve. I took her by the hand, and my heart, it was thumping when she said, hey, man, you crazy or something? You seen what happened last time they started. So yeah, I don't think the gals today are going to have kids after a war, a world war, if that's what would happen. I'm saying it's going to crash. And if it crashes, population's going to crash. And if population crashes to, say, 1% of humanity, no, the girls are not going to restart the race. Forget about that. They're just going to live out their lives. And And yeah, it's one of those things that you really got to ponder all these issues. People think they're going to survive first. They think they're going to trade for food, especially, or they're going to go in there and say, hey, I'm going to carve a niche in this trade business, in this food market that just sprung up. I'm going to make millions. I don't think money will be worth anything after a world war, if a war came to that. But we don't need a war. But the other thing about war that you should be aware of, if there is a war is an economic issue. Why do we war? Why do we fight? Why do we battle? We do war because of resources, okay, and influence, especially over those who have resources. And the ultimate resource of any animal is food. That's it. You need food. You need to secure food. You don't need to go to another country and steal their telephones or their TVs. You need food. That you do need, okay? And so, war is for food, ultimately, and infighting in any species. Most of the infight is for the gals, right? The two bulls fight for the gals. But there's also a fight for food, okay? There's always a struggle for food. So keep that in mind. Food is unavoidable in extinction theories. You cannot avoid it. And people will say, well, that doesn't apply to us. Well, you'll find out you're an animal and you do need food. Okay. The only other thing I should mention about that is, that Calhoun's theory, he carried out experiments with mice and rats, and his utopian experiments always ended up in extinction. And once the population crashed, the colony did not reproduce again. And it wasn't only them. You also had, an experiment. It wasn't really an experiment. It was like they were trying to save some deers, and they put them on St. Matthew's Island. And the deer, they crashed. They lived like 19 years. And when the numbers started coming down, there was nothing stopping them. They didn't reproduce and start coming back up again. No, they went down all the way to extinction. They were able to save the last 20, I think, and one of those was there was only one male, a young male, and that was the only male. All the others were females. I guess women survive more than men. They can take it, we can't. Anyways, I was dealing with geometry, and let me just summarize what I said was it Wednesday, last time? It goes something like this. Geometry is the study of shapes and sizes, okay? That's how it's defined. And yeah, people would like to redefine that. Some people out there would like to do that because it destroys their religion. That's the only reason. Yeah, geometry, you need to have a shape, a size in front of you, especially a shape, right? No shape, no geometry. That's the starting point. You got to have something in front of you, okay? And people don't like to think about that because they think they can do it in the abstract mode, just talk about perimeters or whatever. No, you need the shape. You need some kind of physical object inside there. The itinerary, the perimeter, is simply you tracing that shape. And mathematicians who are already gone, their minds completely blown, they don't want to think in those terms. They want to think completely in abstract terms. They say, hey, I don't need the shapes anymore like Euclid did. Okay, so, but these are people who have gone outside. Anyways, geometry is the foundation of mathematical physics. Okay? Mathematical physics stands on geometry. Everyone claims that the point is the building block of geometry. Okay, so the point is very important because, it's the bread and butter of geometry. You can't do anything without the point or without mentioning the word point. Greeks discovered that, by the way. But everyone casually confesses that they can't define the strategic word point. Nobody knows what a point is. They're staring at it right in front of you, and they don't know what it is. They say, I can't define it. Everyone illustrates a smudge that has width and height. Okay, but then they say that you're staring at what? Despite staring at a 2D dot, the theorist tells you that the point that is in front of your eyes has no size, volume, dimensions, or shape. So we start out a tremendous contradiction in geometry, and that's our starting point. So that's the quicksand on which all of geometry is founded, is based on this undefined point, this thing that they can't define, which is staring at them in their faces, and it's a 2D little dot. And they say, well, the dot's not the point. Well, then why did you put the point in there if the dot is not the point? Take the dot out of there. What is a point? Well, they want to give you the idea, the notion that it's a location. But if the point is a location, it has no place in geometry, because geometry is the study of shapes. What kind of shape is a point if it has no dimensions, no size, no length, width, or height, no volume? Okay, so that's the starting point. We start out on the wrong foot with the point. We have no definition. We don't know what a point is, even though we're staring at it. We don't know what that thing is. It's like staring at a tree and saying, well, I don't know what a tree is. Okay, so these are some of the comments I got. I'm going to go through the comments, show why we're still having problems with the point. I don't know if people have a problem understanding what I'm telling them, the context that I'm presenting. They keep going back to what they were taught in high school and college, and they say, oh no, but this is easy. See, a point is, and what is a point? Let's see. And here we have one fellow says there are two separate definitions of the word point that I encounter daily. Okay, a point variable in video game code is location. Okay, so point is location. Great, we're on top. The only problem there is the location has nothing to do with geometry. Okay, because you need an object, and location is not a physical object. Location is a concept. But let's continue. Referenced by Cartesian coordinates. Cartesian coordinates? What are those? You mean Cartesian number lines? No such thing as a coordinate in mathematics. There's no such thing as a dimension in mathematics. Mathematics has no use whatsoever for length, width, or height. Those are qualitative notions that mathematics has absolutely no use for and never does use. And so they dismiss that, saying, well, that's the informal definition of dimensions or notion of dimensions. No, let's get it straight. Mathematicians don't use dimensions, coordinates, or vectors. Okay, I'll get to that in the future, but none of those belong to mathematics. Mathematics only has number lines. And they call those number lines, alternatively, right, dimensions, coordinates, and vectors. But mathematics has no place for these qualitative notions. They just have room for number lines, and that's what they've been always been dealing with. Okay. Okay, the size of a point is equal to the square or cube of the smallest possible unit length in the game. So we got a little bit of a contradiction here. He started saying that it's a location, okay? Now he says it's a cube. He's talking about smallest length. Well, aside from the fact that I can imagine, a smaller length than you can anytime you want. Just give me any length that you want and chop it up as much, make it as small as you want. I'll cut it in half and beat you. I'll make it smaller. And I can go the other direction too. Imagine the biggest length you can imagine, I'll double it. So I don't know what a small length means. It has no sense in physics. I don't know if it has any notion, any sense in mathematics. Okay, so is the point a location or a cube? I mean, I don't know, judging by what I see there, right? What is the size of a location? I mean, is this 0.05 millimeter cube? Is that the size of a location? I mean, what is it? Are we talking about location, or are we talking about a physical object? And this is the problem. They go back and forth. They don't even realize that they're doing this. Now, for them, this is normal. They say, oh, yeah, see, it's a location. I can locate it with 2 Cartesian coordinates, or 3 or 10 or whatever, and that's the location of this box. and the box is the point, but the point is also this Cartesian coordinate system, the location. So are we talking about structure, or are we talking about the location? And they don't seem to realize. They go around in circles. They never see this. They've been so brainwashed by in high school and college that they don't even ponder these things anymore. Okay, and so here it is, definition number 2 that this fellow is proposing. Let L equal smallest needed unit of length. So he's talking about smallest length. Okay, that's the notion he's introducing here. And he says take an object and slice it. Okay, this would make cubes points of L. So now we have again smallest length. What's that got to do with a cube? And declare any cube, okay, which is a point, right, as 000 and label the rest in a coordinate. That's a point. So is the point the 000, the location, I guess, is it 3 numbers? I get 3 numbers and I have a point. Is that what it is? Or is a point a box? What is a point according to all this stuff? And so if we're cutting carrots, the point is very large. But if we're mincing carrots, the point is very small. So apparently a point has something to do with an object. Is that what he's saying here? Are we talking about an object and saying that if we take a tip of carrot, we got a point? Is that the notion here? And then just to finish off, in both definitions, the point is a counting reference. So yeah, at this point, judging by all that, I have no idea what a point is, because I still don't know if it's a location, a bunch of numbers, a box, a cube. What is a point? You got to define the point, and then you can't say, well, I can't define a point because I don't know what a point is, but let me use the word, and I'm going to use it as everything. I'm going to use it as a box, and I'm going to use it as also the coordinate system that locates the box somewhere. So we got a problem. We got a serious problem here. Okay. And another comment here from another fella says, the notion of a point would assume a granularity. Well, we're talking about a physical object. If you're talking about granular something, I guess you're talking about an object, some kind of bead, a little seed maybe. Is that a point? If there's an absolute coordinate system and location can be quantized, points, middles, and so on exist by definition. Well, aside from the fact that he doesn't understand what the word exist means, you can't apply it to concepts such as points, middles, and so on, and quantized whatever. Aside from that, we got a problem because we got a coordinate system talking about location. How does that square off with granularity? We got a problem here. These people can't seem to tell the difference between an elephant and where the elephant is located in Africa. Those are 2 different things, and these people don't realize that. So they put the 2 concepts into one, and they say, well, it's both. It's the elephant and the location of the elephant are both the point. And also the mass of the elephant, just in case, the location within the elephant, the center of mass or whatever. Okay, it's a concept, doesn't map to anything that's real. It better not, because no concept can be said to be real. Concepts, the word real here is used in ordinary speech and not in a scientific language. Concepts do not exist. Concepts are not real. Only objects can be said to exist and to be real. And that's where, again, people have to learn the language of science before trying to define these terms, because they got to start at square one. You got to know what a definition is, how to define words scientifically, and they haven't learned how to do that. Okay. Okay, another comment, this one I like the most, talks about this as a modern formulation of geometry. Talking about geometry, what? Shapes and sizes, okay? It is done through set theory. Set theory? What is it, TV sets? What kind of set theory is this? And what he talks about, he says natural numbers, rational numbers, real numbers. What numbers? What does numbers have to do with geometry? With shapes and sizes? One size is bigger than another. That's it. That's all we need to know in geometry, right? Or do we need to know anything else? And for sure we need a shape. And these guys haven't noticed that. So what is a set? Well, let's see. Let's find out. Look it up in the diction in the Wikipedia. It says mathematical logic that studies sets, which informally are collections of objects. So a set is a collection of objects. What that has to do with geometry, I have no idea. So how set theory relates to it, so far I can't figure out. That are relevant to mathematics. Collection of objects. The language of set theory can be used to define nearly all mathematical objects. A mathematical object is an abstract object arising in mathematics. In mathematical practice, an object is anything that has been or could be formally defined. Okay, let's see what kind of mathematical objects these people propose as examples, okay? And this is what you'll find. Also from the Wikipedia, it says numbers, integers, permutation. The only one I like out of all these is that one that says derangements. I think there's a lot of derangement in mathematics, especially in geometry, okay? Sets, functions, points, lines, polygons. You know, what is all that? And what does any of that have to do with geometry? That's the other issue that, you know, makes you kind of wonder about these people. So, where does that take us? Well, here's part of that idea that these people have, and that's that we have an entiple. That's what a point is, a three-number system. Okay, so it says just a point is just an entiple, x, y, and z. So it's three numbers. That's what a point is. Or are we talking about a location? Or are we talking about what's in that location? Okay, so these are the things that people have to settle. And they have not been able to, you know, resolve these issues after all these years. Okay, let's continue here. Where did we get all this stuff? Let me get this thing out. Where did we get all this stuff? Well, we got it, like I said the other day, we got it from Mr. Euclid. Okay, and see if we can get them here. So many of these sometimes, can't find them. And Euclid, in his book Elements, he said a point is that which has no part. Okay? And he said the end of the lines are points. So where did he get this? Well, he wasn't the first one to formulate this. Remember, he came a little after Aristotle, and Aristotle already put that in his book. If you look at Sixth Book of Physics from Aristotle, he says the extremities of 2 points can either be one, can neither be one nor together. And he puts under in parentheses there, that which has no parts. So what were they talking about? Well, they were both of them. They were talking about the atom, okay? Because that which has no part was an indivisible, okay? And that indivisible was Democritus or Leucippus' atom. That's the indivisible. So whenever they use the term indivisible, they're referring to that. What were they talking about, especially Aristotle here? Well, Aristotle got this notion that he had to explain continuity, okay? And the problem there is that he starts using the point to explain continuity, but he brings in subject matter that has nothing to do with geometry, or it has to do with geometry only tangentially, okay? So he uses length. He brings in the word length. He brings in the word time. Okay, he says again, if length and time could thus be composed of indivisibles, meaning the atom, right, meaning the point, okay, because they're talking about a point that is indivisible, okay, and that's what these people had in mind as far as the atom and how the world is structured out there. Says they could be divided into indivisibles, since each is divisible into the parts of which it is composed. No continuous thing is divisible into things without parts. Okay? Nor can there be anything of any other kind intermediate between the parts or between the moments. Now he brings in time. So we're talking about parts, which means an object, okay? We're talking about moments. And as you can see at the end there, without going through all this, you can see he introduces also magnitude and motion. So we're talking about like 4 different things that, or different concepts that Aristotle introduces in his book. And this is going to be the foundation of not only of Euclid's geometry, but what we have today. In fact, all this has to do with what we have today. We're using magnitudes, we talk about time, we talk about motion, and we talk about the indivisibles, which we discovered was divisible, if we were talking about the atom, right? But it says up there, it is plain that everything continuous is divisible into divisibles. What is he talking about? He's saying, if you look at those boxes that I drew there, the cubes, the last one has parts to it. He says you absolutely need to have each one of these boxes made of something. In other words, they have to be divisible as well. Because otherwise you're going to have what he says there, we're going to have an indivisible in contact with another indivisible. One atom in contact with another, and then they cannot be continuous. You have to be able to break that one up as well. And so he was essentially challenging Democritus with this notion of continuity. Okay, let me get this here. And well, again, if you look at my point, I don't know what they're talking about, because my point shows that point has height and width. Okay, that's my point, because that's what I see in front of me. That's objectively what's in front of me, without having to second guess anyone. That's straightforward. Okay, but again, what Aristotle was trying to do, he was trying to challenge the notion of the atomic notion. Okay, and he says he was talking about continuity, but then he uses the word continuity in several different ways. He uses it for structure, like a continuous structure. He uses it for time. He uses it for motion. What is he referring to? And if you go through that whole book number 6, has several sections to it. It's a big mumble jumble. He keeps giving examples of, introducing examples that constantly change on you. Maybe he's talking about structure, suddenly he jumps into time, and then he jumps into motion and back to structure. And so, yeah, it's very confusing, because the examples he gives shows that he's rambling. That's what he's doing. He's just, he doesn't have his thoughts straight. And we've inherited this notion of continuity, the word continuous, from him, essentially. This is the notion we find in the dictionary today. Uninterrupted in time. Is that what continuous means? I thought continuous was an adjective. See, you can say a table is continuous. But if you're going to talk about time or without cessation, which refers to motion, that's incessant. You never say that a table is incessant unless it's moving, right? Incessantly. No, motion can be said to be incessant. But that's different than saying that a table is incessant. No, a table is continuous, if anything, right? And motion is incessant. And these people have used the word continuous always to qualify motion. As you see there, uninterrupted in time without cessation. That comes from Aristotle, because he's the guy that comes up with these notions to begin with, or at least one of the first one. Maybe there was someone before him, right? And it says being in immediate connection or spatial relationship. Okay, a continuous series of blasts or a continuous row of warehouses. Again, a series of blasts, that's not continuous. Those are not objects. Those are phenomena. You can say one right after another. That's got to do with time and motion. And a continuous row of warehouses, that's not continuous either. Because what you're doing is chopping up each house and you're putting them together, like even if they're touching surface to surface. Okay? And if you do that, do you have a continuous row of houses? No, you have discrete houses comprising this elongated thing, okay? And that's what Aristotle was referring to. He was saying that you build the continuous with these divisibles. And that sounds so terrible, especially for physics, okay? So bear with me a minute, I'm going to get to that. Let me just say that here they built from that the notion that we have today of space-time, okay? And that's the continuum. Okay, and the continuum is in other words, they turned the adjective and they turned it into a noun. Okay, we went from continuous, the adjective, which is applied to verbs, to motion, to time, and now they're going to take that word and they're going to apply it to, they're going to turn this adjective into a noun. Okay, continuous series of elements or items that vary by such tiny differences that they do not seem to differ from each other. Okay, an example of a continuum is a range of temperatures. Okay, a continuous whole, quantity, or series, thing whose parts cannot be separated or separately discerned. Okay, so they're turning this adjective into a thing. And what do they end up with all that? You know, you can go through the rest of the definitions there, but what do they end up with all that? Well, they end up with this monster here, which they call space-time. Okay, and you can see that this is, you'll find this on the internet. It says space-time is a mathematical model that joins space and time into a single idea called a continuum. They also refer to it as a manifold. What is a manifold? Well, a manifold is a continuum. What did you understand? So what you're staring at, that four-dimensional continuum, right, is known as a Minkowski space. So space is continuous, or continuum, I guess. It's a physical object, it's a manifold. So they turn this, and what is it made of? Made of events. What is an event? A point in space-time. So there we get the point back again. It's all circular, okay? It all comes down to the point. What is a point? A point is what is an event? An event is a point in space-time. You take all these points and you build a continuum. And the question is, at this point, once you look at what Aristotle proposed with all these notions regarding the point and how it fits into this notion of continuum, especially the continuous line, and his notion was that if you chop it up, you're going to get all these points. And each one of those points got to be divisible as well, otherwise, you don't have a continuum. Okay, and that's his notion. Well, here are the questions for you. This is for homework, okay? Anyone who wants to take this on, okay? And here it is. These are the questions for you. Let me put this back up here. And so the question is continuum made of points, or is it a single piece? Okay? Are we talking about something made of discrete parts of segments? Or are we talking about something that is made of a single piece across, whether a line or a point? Because again, what Aristotle is saying is that point there is also, it should be made of parts, otherwise you can't build a continuum such as the line below. That's what he's saying. And remember, these notions are the ones that were inherited by the mathematical physicists. Okay? And these are the notions that we have today in geometry. Okay, here's another question. Again, are we talking about continuous movement? Are we talking about motion or a continuous structure? What does the word continuous refer to? Is it an adjective or an adverb? See, continuous, as far as I know, is an adjective, and you can use it to qualify structure, architecture, or whatever, bodies. But you can't use it to say continuous motion. Not in science. You can use that in ordinary speech, in non-scientific language, but you can't use the word continuous to qualify motion. No, the word is incessant. And incessant, for the purposes of physics, is an adverb, not an adjective. Incessant can only qualify motion. And so the point, if it moves, like it's moving up there, then you can say it's moving incessantly, or it's incessant motion, if you want to use that term. But you can't say it's continuous motion. Continuous only refers to structure, science again, for physics versus ordinary speech. Okay, so what the mathematicians are using here, and have been for 2,000 years, is ordinary speech, informal language, and language that has not been defined, by the way. Okay, here's another one, also dealing with continuity, but the question is our dot, our point, is it 2D or 3D? Is it an abstraction, or is it physical? Are we talking about the real world? Because if it's not part of the real world, what are we using points for? And how are we relating the points, the abstract points, to the real world? That's the issue. So the question here, you got 3D balls at the bottom and 2D plates, dots at the top. What is a point? Is it 2D? Is it 3D? Is it, and here's more. Here's another one also dealing with continuity. By the way, are we talking about continuous numbers, the number line, real numbers or natural numbers or whatever? Or are we dealing with dots? Are we dealing with balls, plates, dots, whatever? What does continuous refer to, and what does the point refer to? Is the point a number? Is that what a point is? Are we just going to use the point and say that not only location, but are we just going to give a number to a point and say, well, that's point number 5? Is that what a point is, a number? And or are we going to put a dot? Are we going to put a little ball? You can't. The problem is that they put all these notions into the same word, point. That's the problem. And so people don't realize that the word point means all these things for a mathematician, because on the one hand he's talking in abstract mode, but on the other he wants to make sure that you understand that he can describe with his points, with his numbers, with his equations, that he can describe the real world out there. So he does want to relate it to the physical world. Otherwise, what's the purpose of math? Just an abstract discipline with no relation to reality? No, he's got to try to link it to reality. He's got to try to link it to physics, ergo, mathematical physics. They have to tie the knot between physics and mathematics, and again, geometry is that, that connection. Geometry is the point of connection. And again, what they've done is mix concepts with objects. The object is the dot, and the concept in this case is the numbers, but then you also have concepts such as location. And location is not what you thought location is, not in mathematics. Location is a set of number lines, not coordinates, not dimensions, but number lines that allow you to tell how far something is from something else. That's all it is. It's just a bunch of number lines. So don't call them coordinates. It's the wrong word to use. No coordinates in mathematics. Okay, and here's another question for you. Again, locations are numbers. What is a dot or a point? Is it a number or is it a location? Which one is it? These are things people don't realize that is in front of them. And for as much as I talk, it's like many people just don't get it because they've been so conditioned to use that nice word. They've been conditioned in high school and college to think of these things, as no problem. They don't see a problem with all this. Location, numbers, dots. Put them all together. Yeah, it's everything. I like to say that the word point is the god of mathematics. Truly is. Okay, because it's more powerful than God. Point can do anything. Okay, so are we talking about a distance traveled, or are we talking about a separation between 2 points? For example, when you look at a line, right, which we're going to look at further on, you get a line, and they say the 2 endpoints are points, right? Okay, the 2 things that clog the ends of this line are points. So are we talking about two dots that are separated by some distance? Or are we talking about one dot, one thing concentrated into a location, and that location moving all the way to the other side? So are we talking about one object or two objects? Is it one object that is moving, or is it separation between two objects? All these questions are things that mathematicians have not resolved because they're all qualitative. And they don't deal with qualitative stuff. They deal only with quantitative stuff, so they just bypass all this stuff. But the problem is then they make inferences about the real world, about the world out there, from all these abstractions. And they claim they have proven them because they've proven it mathematically, not because they've proven it in any way out there with some kind of, how do you prove an invisible entity, the existence of an invisible entity such as a photon? What do? You're going to bring it to me and show me and say, see, I've proven it? You can't see it, you can't touch it, whatever the mechanism is there, right? The mediator, the agent, you can't touch that, you can't see it, but you say you've proven it, and you've proven it mathematically with an equation? These are the issues. And here's another one, again, for those who wish to take it as homework. Okay. Seconds or meters? Are we talking about time, or are we talking about something you're going to measure like with a ruler? What is this dot that is moving? Is it moving according to time? Are we going to time it and measure it in seconds, or are we going to measure it in meters? So we got all these issues where these things are not clarified or better yet, what happens, they've included all these notions into one. That's the problem. So they get away with murder because they can jump from one notion to another without any problem, because they've already included all these notions inside the point and what the point does, because they're going to get into a line. The line's going to be continuous. And what do they mean by continuous? That it's chopped up into points. And so this is my definition. Continuous, a hypothetical object made of a single piece. That's what it means in physics. That's what continuous means. It's an adjective. If you want to qualify motion, you got to use the other word, incessant. That's not my definition, but I'll accept it. It's the definition you'll find in the dictionary. Continuing without interruption, ceaseless, unending. Not unending if we're talking about structure. Okay, unending only if you're talking about motion. But ceaseless, incessant, incessantly, those are the words, or perpetual. Those words refer to motion. Okay, whereas continuous, refers to objects. And a similar notion, which I'll probably cover in the future, is the word straight. Straight is an adjective. You can apply it only to objects. Rectilinearly is what you apply to motion. So we got to distinguish adjectives from adverbs, and mathematicians have a hard time with that because they constantly use adjectives to qualify motion. And that's okay in ordinary speech, not in scientific language. Okay. Anyways, I'll be continuing with this line of questioning and wondering about geometry, especially the foundations of geometry. I'll be dealing with that on next time around. Sunday? And I just want to make sure that people understand what the problem, what the issues are that I'm trying to get through. And that is that what they've done with a point is put lots of concepts into one. And the first one starts with the point itself. Is it a dot that you're staring at, which is objectively in front of you? Or is it a location? That's the first one. But then it doesn't stop there. Then they say, well, it's a location, but we don't care about the location, like the physical location of the Earth in the universe. You say, okay, it's the distance to every object in the universe. That's not their notion. What they do is put a frame of reference, and they say, well, what we have is It's like finding the treasure chest, pirate's treasure chest. Walk 10 feet this way, 5 feet that way, and 3 upwards the mountain, and you'll find the treasure chest. That's what a point is to them. It's the point. It's not the point, but it's how to get there. It's, so this notion about position, which is very close to the word point, is just a way to get there. Even position is a dynamic concept in mathematics. You take 5 along the x and 3 along the y and reach the point. And so you put x, y, you get 5, 3, and that's the point. The point of what? What do you mean the point? The point is 2 numbers? Yeah, it's an ordered pair. What do you mean by that? I need 2 coordinates to get there. So all these concepts have been rolled into one. And again, you say, well, what does that have to do with geometry? Okay? So that's one issue. The other one is this notion that Aristotle raises, which is crucial for the point as well, which is continuity. Do we need the point to explain continuity? And why did he introduce that? Because he's going to go into the line. And the line is not what you thought a line is. A line is an itinerary in mathematics. There is no such thing as a line. Mathematics has no use, or geometry has no use for a line. Not modern geometry. Real geometry does, but fake geometry, which is what these people do, they're talking about itineraries, always, trajectories. So when they talk about line, it's not a line. It's not a geometric line. It's an itinerary. You're going to be measuring something. You're going to unroll the measuring tape. Okay, so keep that in mind. When they talk about line, it's not a line. It's an itinerary. What is the itinerary made of? What is that motion made of? Locations. What is a location? A point. So we have all these points making up locations, right? Making up motion. And that's what mathematics deals with. And they call the location, they call it a point. And the itinerary, they call a line. And people get confused because they say, well, hold it. A point is that dot, and a line is that little elongated thing that you drew on the board. Well, yeah, that's just a pictorial representation of a line. Then what do you mean by a line? Well, the line is really the itinerary. It's the motion. It's the unrolling of the measuring tape, because what we're going to be doing is measuring. That's what geometry is about, they claim. And that's the foundation of mathematical physics. So I just want to make sure you understand the main points that I'm trying to get across. And I'm not sure everybody does get it, because they've been so conditioned by what they've been taught in high school in mathematics and college, as some of these people showed there, where they just reproduce and say, yeah, see, it's a little cube, and it's also the location of the cube. Here's the coordinate system. So, which is the point? Okay, so we'll see you on Sunday. And I'm going to continue with geometry. So if you are interested in learning a little more about what lines are, we're going to get into planes, dimensions, and we're going to have a little bit of fun here. Okay, we'll see you on Sunday. Bye-bye.